Hi YouTuber, we have a Hayward SP3400VSP pool pump in here that is not working, and I'm gonna explain to you guys how can you fix the control module on them. I'm assuming that your pump is okay, the motor actually is okay, and the control module doesn't work. So I explained to you guys how can you fixing that. I'm assuming that when the pump doesn't work, you already check your power supply, make sure your power supply is okay, and you use this little cage right in here. You open them up and you're moving your motor, make sure that it's moving freely, it's nothing stuck on them, and it's nothing wrong physically with a motor, and the control module is bad. And when you opening the controller in the top, you will see the error light, a red light is coming right in here. Every time you're resetting the system, motor just making a clicking sound a bit, and then the red light is coming on. That is telling you something is wrong with your control module, and I show you how you can fix it. So to doing so, of course, you have to disassemble the, as I mentioned, this is a SP3400VSP Hayward ECO Star. This is 3 horsepower motor. So you already know you can open this part with removing these screws. I'm assuming you already knowing that because you disconnect the power supply from it. So when you're removing this thing, you will gonna see inside of this from the hole that is right in here. Of course, I put this thing back together again without putting all the screws together. So some of the stuff is not in the same place that it's supposed to be. One of them is going to be all of these 3 wire that you see is coming. It should come through this hole up and then be connected to this connector, the jack that you do have right in here, 3 jack right in here. You disconnect all of these 3 wires first, and then you can use the ohm meter, measure between the 2 of this wire. You can use any kind of ohm meter that you do have. Between the 2 of this, it's supposed to be half an ohm or 0.7 ohm. And between each one of these wire and the ground, you should not have any ohmic resistivity, or if it is, it's going to be in several megs. So you go ahead and they do have 4 screws in the bottom to removing this module right in here. I don't know if you'll be able to, the whole module right in here. It has 4 screws from the bottom. You have to loosen them up and get rid of those screws right in here, and the other side. After you're doing so, slowly remove the module a little to the back and start pushing this wire back through this hole and releasing the wire to the other side. That you'll be able to remove the top part of this module, just like this. See, when I tried right now, of course, the wire that I was mentioning in the bottom is not in a hole, so it's not going to be any obstruction for me to removing the module. But when you're trying to do so, you have to remove the wire, push the wire inside the hole. Let me just get a better picture. Push the wire one by one inside the hole without damaging the jack, and then it's allowing you to remove the module after getting rid of the 4 screws in the bottom. So when you're removing them, it's going to be this is going to be the module like this. In the bottom, it has a fan on them. You can see like this. They building them this way that the fan that is moving in the back of the motor is cooling this module at the same time too, because this is actually working as a heat sink for all of the component that is been installed on top of it. We will see it later on. So I already told you how you can check the motor. You already checked your motor. This is a permanent magnet motor, 3-phase. So you already check between each one of these 2 poles that you do have. It's supposed to be half an ohm till 0.7 ohm, and no resistivity is supposed to have, or high resistivity. You're supposed to have very high resistivity between each one of these pole and the ground. So, and the motor, of course, is you can move it by finger. It's moving freely. So you know it's nothing wrong with a mechanical right in here. Whatever we have a problem is going to be with the control module. So now let's just get after control module. We separate this thing. You can flip them over, and when you flipping them over, you will see in the bottom, you do have a 4 screws that is already been removed for me. Right in here, right in here, right in here, right in here. You're removing those screws and you're trying to split the 2 pieces apart. It's not going to be easy because they're using some sort of the silicone glue on that when they put them together to make the system waterproof. So you have to start using the distance between this, the crack that is between these 2 pieces. Use a screwdriver and pry bar it. Eventually the 2 pieces they come in a piece. For me, it's going to be right now after I remove them for the first time. If I move them right now, you will see it's coming easily apart. But as I said, if it's your first time to doing this, it's going to be very hard because of that glue. And then when I put this thing back together permanently, I'm going to use again some sort of the silicone to sealing this thing well. So let me just split these 2 apart. It's just splitting them apart as I'm doing it. So right there. It has a little jack that is connecting the timer that is in the top of, it's coming from the top of the control board to the bottom. You have to release the jack. Let me just show this jack. I'm going to release the jack and then you can put the top part away. Well, we're going to start dealing with the bottom part that has a motherboard on it. So we do need to remove this motherboard because most of the component that actually essential to this board, they are in the bottom side of it and is no way to removing them easily. The reason is all of the component that been installed on this, the big component that have been installed on this, if you're looking at it from the side, like this capacitor, big capacitor that we do have right in here, or the coil that is in this side, or the transformer that is in that corner, or the other coil that is right in here, they are embedded inside some sort of the glue. To prevent them from movement and probably for the heat transformation. So the only way that you can remove the motherboard is disconnecting all those components from the motherboard. To doing so, you have to do 18 desoldering point. That is going to be 2 for this capacitor, 2 for the other capacitor, and 2 for this coil. One is right in here, one is right in here. And the other side, there you have a transformer that is changing the voltage from the 240 to the approximately 15 volt or so, somewhere between 12 to 24 volt. That is using for the bias voltage of all of the circuitry that we do have right in here. So you desoldering all of this 4 point right in here and the other 4 point in the other side. Some of this point on this side, because they are a high voltage, they do have some sort of the silicone glue in top of it. So you can just peel them off before removing the solder. Then you do have another 4 point right in here that you need to desolder and remove the solder. Make sure no solder gonna left, and be careful when you're using the heat gun or I don't know, solder gun, that you don't delaminate the board. After doing so, you do have 6 screws that is tying up this motherboard to the heatsink or the chassis. They are going to be 4 in the corners and 1 in the top part right in here, one ground right in here. Beside that, you do have another 5 or 6 screws that is tying up all of the component that they like the FET, like the bridge, like the big IC chip that is sitting right in here that I already removed them. When I remove them, you will see it. Those are going to go through this through hole. You seen these holes right in here. You have to remove all those screws too. After you're removing all of those screws, at least at the end when you're looking from the top, any screws that you see to the board, and I'm not talking about terminals right in here, must be removed. Beside that, you do have a 2 wire right in here. In my case, it's blue, and they used to have in top of it the piece of what do you call silicone glue on them too. You have to remove these 2 wires too. This is going to be some sort of the temperature resistor temperature. They call them diac or something like that. That is controlling the control temperature for it. So it's no way of removing the board without removing these 2 wires. So remove these 2 wires. You don't need to tag them because it doesn't have a polarity. And then later on you can put them back together. Long story short, after you removed all of those solder points that I pointed at you guys, then you should be able to use the little heat gun on the side, because they do have some glue between all of this component and the board too. Heat them up slowly, and at the same time remove all the screws and start pushing the board upward. Let me just remove these screws from this corner and this corner. Let me see if I can turn these lights on that we can see them better too. Okay, so after you removing all these screws, then you should be able to remove the board. Of course, I'm showing him right now to you guys. It's very easy because I already done this one before, and I just put this thing back together loosely to just showing it to you what you have to do. It's going to be a little more work need to be done because you do have a glues between right in here, right in here, right in here that they need to be heated up, and start pushing this board on and separating the motherboard from the chassis. And when you're removing them, you're going to end up something like this. You can see all the components that they reside back again in the chassis. And as you see, it's very hard. I'm not saying it's impossible, but there's no way to removing this component. As you see, they are embedded inside some sort of the glue. And then you can start cleaning all the extra solder that you do have in all of these pins, because you need to put this thing back together. And this is going to be the component that I told you. You couldn't get to these screws from the top. Other than that, we didn't need to remove these two wire. So we have to remove the wire, and then when we're done with it, we put the board together. We're going to solder them back again. Okay. So as you see right in here, this is the footprint of all of the component that they were sitting from the motherboard right in here, the back of the component, and like a FET, like a breach, like they do have a resistor right in here, and the big IC chip right in here. And the main problem is coming from this IC chip. I will elaborate about that one a little more later on. So I didn't have, as you know, it's very hard, or I don't have a schematic of this circuitry. So I have to remove the board, and I have to remove the component, and to be able to take a look at them, get a spec for them, and check them one by one to see if they do whatever they're supposed to do. So after we flip this board, now I'm going to flip, you see the side that we couldn't see. We were seeing this side. Now after we remove the board, we'll be able to see the other side of the board. Of course, whatever you see right now is missing the big chip that I removed from this place right in here. And that was the one that was actually causing the problem for my circuit. I checked this is the breach right in here in this corner. It's okay, there's nothing wrong with it. I do have a FET right in here, another FET right in here. They are okay, there's nothing wrong with them. It's a bunch of the diode, and everything is in the output side, is pretty much symmetric, 3 of them for the 3 phase that they generating. I checked those are okay. We do have a microcontroller right in here made by the ST. Hopefully is nothing wrong with it, and is the chance that something goes wrong with the microcontroller if the water doesn't get to it and it start rusting and rotting the stuff around this. Probably your microcontroller should be okay. The main part is going to be this IC chip that is sitting right in here, because of the different frequency and the power that it goes through it. It might get very hot, and if it doesn't cool off correctly, or the chip is going to be some sort of the defective, it's going to go bad. In my case, one of them, it goes bad. So after I remove that and I take a look at it, let me just show you the chip that it was right there. Okay, right in here. This was the chip that I removed. This was the chip that I removed from that point. I couldn't see the model number out of it that I can check on before I tearing them apart. So I have to take them apart, read the model number, get in the internet and Google them and get a spec sheet. After I find out what is going to be the spec sheet for it, this is going to be the spec sheet for that device. As you can see, the part number is in the top, and what that IC chip is going to do, or integrated circuitry is going to do, is some sort of the power hybrid IC for the appliances motor drive application. So if you just go a little farther in and you take a look at the schematic of the circuitry in the chip, you will see something like this, and it's going to give you a little bit of information how you can check between the pins and to see. Of course, you don't have access to all of the component in a chip, but the power component that it shows in the top, you get some sort of the access to the pin, of course not to the gate of it, but to the drain and source, and then you can just do some sort of the measurement, transistor measurement, and find out if they are good or bad. In my scenario, this transistor right in here, as you see, we do have 3 parallel for the 3 phase. That is going to be for the positive side and negative side for each one of those 3 phase that is coming up and is connecting to your motor right there. So this transistor was shorted, and that is causing the whole circuitry to not to work. So I ordered that chip. It's coming in as I show you again. This is the model number for it. You can get them from the eBay. Cost you about $20–25, and then after we put them back together, hopefully everything start working. So again, I need to emphasize on this that when you're trying to desolder and get this board, do the clean job. Make sure you don't delaminate, and after you separate this board from the component, do the cleanup, and make sure all of those pin that you do have, they are aligned with a socket that is going to be right in here, that you need to put them back together. All of this, they're going to be aligned with a pin. Other than that, you're going to have a very hard time putting this thing back together, especially about the 8 pin that you do have right in here for this transformer. So I already tried it, and I put them back, and everything was aligned pretty good. So the only thing that it left, I have to get that IC chip, putting them back together, and put everything back together. Hopefully everything start running. Some stuff that we can do about it, I learned about this. This motor right in here that we do have is a 3-phase permanent magnet rotor on it, and it's a 6-pole on it. So if we know how many poles is in there, we do have a formula that you can define what speed you're going to run based on the watt frequency. Since this motor is supposed to run somewhere between 600 RPM till about almost 3500 RPM, so the frequency is supposed to be somewhere between 30 Hertz till 180 Hertz. And if you take a look at the spec right in here on the tag that it said the maximum frequency that this motor is supposed to have is about, I don't know if you can zoom on me. Let me just see. No, it's not zoom. I don't know if this thing can be zoomed well. Alright, it shows right there about 180 Hertz is the maximum frequency that you can put in, and it shows what is the maximum voltage and the other parameter of the electrical parameter of the motor. So that's about it. Now after I put them back again together, I'm going to have a video. I'm going to prepare another video and show you if this thing does work or not. Besides having the reason that I started repairing this board, because this board is about $800, $700. They don't sell the board. They're selling the whole module that is included of the timer that is going to be in the top of it. And I ordered a new pump actually to come in, and I challenged myself, since that I'm an electrical engineer, to see if I can repair this one and keep them as a spare and have some sort of the better view of the, in case if it does happen, how to repair it. That's about it. Okay, now I put everything back together. Now it's going to be a moment of the truth. Let me just plug them in to the 230 volt, and then we'll see if the motor is going to run or is going to set the place in the fire. Alright. So far so good. Let's see. Alright. Seems like it's running. Well, seems like we are back in the business.